18, I think we don't need to solve 18 because it's a trivial. G of x, because I already corrupted the question. I messed up the opportunity. Equals to, I think it's clear to you that you can see right now that this function is just the left part of this function. If you want just to plot it, you will find it just the left part. And to find the domain to this function, I need to put the expression inside the square root greater than or equal to 0. I'm going to divide, to multiply or divide by -1. The result will be x less than or equal 0. So the domain of the function f is just the numbers. See, we can write it that way, and we can write it in our old way that we used in our lectures that titled concepts and the skills. So now we're going to plot this function. The plot will be just like that one, but as you know, I can't, when I plot my table, when I take my table x and y equal to the square root of minus x, y and then x, you know, here I can't take just the positive numbers. I can take just negative numbers because the domain of my function is just the minus numbers or the negative numbers and the 0. Because if you, I want you to know, when you take these numbers on the left and substitute them in the function, you need to take them from the domain. Don't forget to take them from an interval or a set that is not contains in the domain. So 0, Christmas, that's it, fireworks. -1, -2. Yeah, I think about 5 hours will the next year will start, and this is my next year. I'm just filming. Y equals to the square root of -0. The result will be 0 and 0, 0. And y equals to -1, -1. See, minus, the result will be the square root of +1, which is 1, and -1, 1. See? And the other one is just the square root of -2, which will be +2. So the square root of +2 -2. And the plot will be exactly that one. Exactly that one. So I'm going to plot it here, just for quick. We have 0. I'm just looking to the camera in case, because I have 30 minutes limit. -1 and 1. -1. -2. So this is the plot of the function, which is the left half of this function. I think we solved these functions, and we now move to the other last two functions. Now we're going to solve the last two questions. The first question is 19. No, not the first question. The first question now in the set, which is f. I want to mention something. The capital here, it's not accident. It means something, but it's not now. It's not the right time to explain why did we put capital F in here and capital G instead of just F and G's in the small letters. Will we know this? We will know this notation when we reach integration and the integration of the len or logarithm, natural logarithm function. We can see now the domain of this function. The domain of this function, domain of capital F, will be all the real numbers but but 0. Okay, or we can just denote it in this way. Domain, the function f, will be minus and 0, union 0. The 0 is not included. Okay, And to plot this function, it's a linear function. How? I have two functions here, but for now let me use the table, because in the next set of questions, I'm going to use not this set. I think the set after the next one. I'm going to solve a question that relates to piecewise function, which is in which we can just analyze the function and solve it in another way, graph it in another way. So here I'm going to use the table method. I'm going to take 3 points here. Why? Because it's a linear. Because if I want to analyze this, the reality of this function is just f of x equals to, this is 1t, and this is a plus minus t, and the result will be plus minus 1. The result will be plus 1 and minus 1, and you will see right now. Going to make the table small, x, and I'm going to take it t, and I'm going to have it like y. Let me just denote it y for now. Let me call this y. Zero, not 0, I can't take 0. I can take just 1 on absolute 1. And I'm going to take minus 1. Minus 1 on absolute value of minus 1, the result will be just minus 1. Minus 1 and minus 1. And I'm going to take 2 plus 2. Y will be 2 on absolute value of 2, and the result will be 1 and 2. And here I'm going to take minus 1. Minus 1 on the absolute value of minus 1, and the result will be minus 1 on, minus 2 on the absolute value of minus 2 will be minus 2 on just 2, so minus 2. Here minus 2 and minus 1, because minus 2 on just 2, minus 1. Okay. If we want to plot this function, the plot will be, as I'm going to explain to you. I'm going to plot it right now. I'm going to have the 0 is not included, and I'm going to plot the first point, which is 1.1. 1.1. This is 1.1. I'm going to plot also 2 and 1. And the 3 will be also 1, and the 4 will be also 1, and so on. And in case of the negative numbers, minus 1 will be just with minus 1, minus 2 will be just with minus 2, minus 3 will be minus 3. And we can see easily that the plot of these functions is just a line, which is here y equal 1, and here a line 2, which is equal to y equal minus 1. That's why I told you the final plot for this function is just 2 lines. For the interval, which is from 0 to infinity, the plot will be just positive 1, y equal to 1. And for this interval, minus from 0 to minus infinity, or from minus infinity to 0, the plot will be just y equal to minus 1. Okay? The last example that we have today, example number 20, g of t equals to we need to plot, we're going to make a table. We know that the domain of this function, which is g, equals to r minus the 0, because the only number that makes problem for me is the 0 when I substitute it in the denominator. So let's plot the table first. X equal to, let's call this, for example, y, for simplicity. So y here, and then we're going to take x, y. It's not xy, we put xy here, it's not xy, actually it's t, y. It's just a matter of notation. It's not something wrong, just t and y, same thing. So I'm going to plot here t, and here t, and this is just, we can just plot a g for example, just g. It has nothing to do with the notation, it's just notation. We need the concept, but we have to respect the notation. But conceptually, it's just a notation. So we're going to apply 1 plus 1 minus 1. Going to do it, going to plot plus 1 and minus 1. So g will be a plus 1, because I have its absolute value, and you know the absolute, it's easy, will be 1 on 1, and the point will be 1 on 1. And I'm going to have a plus minus 2. The result will be g just 1 divided by plus minus 2, absolute value of a plus minus 2, and the result will be just 1 divided by 2, and the result will be 1 and half. Okay, I'm going to take just a third point. I'm going to take a plus minus half. So the result will be g equal to 1 divided by the absolute value of 1, and the result will be 1 divided by 2 on the denominator. I'm going to rotate it, so the result will be just 2. Okay, if we have a fraction, for example, xy divided by a and c, we have a skill here. We say that we bring the fraction in the numerator in the top and put it as it, and then we're going to plot it by the reciprocal of this one, which is c on a. Okay, I said the word in Arabic, which is khosh. That means cool. So a plus minus, no, this is not 1. This is a plus minus 2. You need to correct me. This will be a plus minus half, and here we have 2. Now we need to plot this one. To plot it, I need to clear the board. So I completed the table right now. You can choose another point, for example. You can just choose, for example, plus minus 3. You can do it as a homework to you, and plus minus 1.3. And you will know now why I chose these points. So I'm going to make a big axis that I can make it clear. I'm going to put that 1. And now I'm going to make it, this is 1, and this is 2, and this is 1, this is 1, and this is 2, minus 1, minus 2. The first point is just 1 by 1. 1 by 1, which is here. Okay? No, this is a plus minus 1, which is 2 points. The first point, a plus 1, a plus 1 and 1, and the second point is just minus 1 and plus 1. See, I almost minus 1 or plus 1. Here we can we find the point which is a plus 2 minus 2 and a half. So we have a plus 2 and a half, which is this one. This is the half here. So plus 1, a plus 2 with a half. 2 and a half. Same thing with the other side, with the negative side. Of minus 2 and a half. Okay? Now we have plus minus half with 2. So we're going to assign, this is the half here, this is the half here, and this goes with 2. A plus half and 2. Half, a plus half, and 2. We have minus half, this is a plus half. And this is minus half. Okay? With 2 also. Plus half or minus half with 2. So now, if we wanted to plot the function, the plot will be no, not that. It's not really perfect, but it's called a sketch. Sometimes they call it graph. See? And when we take the piecewise function in the future, we will know that this function, which is g of x, I'm going to analyze it. You don't need this. This is just extra information. 1 divided by t, you will know divided by absolute value of t. You will know that we will divide this in 2 functions. The first one on t and the second one on minus t. So g of t will divide two functions. The first one is just 1 on t and the second one minus 1 on t. And this is the graph of the function. G of t equal to 1 on t, and this is the graph, this half, and this half for the function g of t equal to minus 1 on t. But when we put the absolute value to the variable t, we made 2 functions in 1 function. We call this implicit. We have 2 halves of the graph, 2 halves or 2 functions as 2 halves, just implicitly collapsed in 1 function. I insist, or I emphasize that you don't need this analysis. If the teacher or examiner told you just graph the function, just you need to make the table and to plot it that way. But we will have another kind, which is advanced method to plot the functions. We will take it in chapter 3, the applications of differentiation. I see you again in the next lectures. Thank you for your watching.